This is recitation 7. We work with time-independent circuits, and this is problem 3. So this circuit was put together long time ago, which means that steady state is reached. Steady state. Sorry, this is A. Steady state has been reached, which means that current and current densities do not depend on time. All resistance, resistances and all capacitances and all voltages across the batteries are given. C's, R's, and V's are given. We need to find all currents in this circuit, and we need to find all charges on the capacitors. So currents and charges on the capacitors. So we will follow the steps as always when we work with circuits, and first of all we write the laws that we will use. Integral E dot dr closed loop is equal to 0, and continuity equation. Integral flux of current density J through closed surface is 0. I also remind you two more things. So if you consider difference in the electric potential, V at R2 minus V at R1, this is equal to minus integral E dot dr. From R1 to R2, this minus is important. This means that delta V has opposite sign to E dot dr. And I also remind you that if we have a steady state situation, for steady state situation, current through the capacitor is 0. If I have a capacitor in a certain branch, then current is 0. One more thing. When we work with the resistors, voltage change across a resistor, delta V, magnitude, is equal to IR. And when we work with the capacitors of capacitance C, this is R, this is C, then delta V across a capacitor is Q charge divided by C. Okay, now let's come back to this problem. So when you work a similar problem on the test, you need to indicate the laws that you are using. You don't need to write all this, but the laws have to be there, and then we follow the steps. First of all, we need to choose the direction of current. We need to start, we have two batteries, V1 and V2. I will start with this battery. So we will have current I that will be flowing in this direction. Then it comes to this junction, and it continues going this way. And I remind you that current through the capacitor in steady state is 0. So this is not really junction. Current keeps flowing this way. And then I keep going. Current comes to this junction. And again, we have a capacitor in this part of the circuit. So no current through this capacitor in the steady state situation. So current will flowing this way through this resistor back here, and we don't have any junctions in reality. We have just one current flowing in this circuit that we need to find. Wonderful. So step number 1, direction of current. Now we need to indicate the charges on the capacitor. I remind you that the problem will not be graded if we don't have charges on the capacitor. So which plate will be positive, which plate will be negative. I will choose this plate to be positive. We will put plus Q1 here and minus Q1 on this side. For this capacitor, for a change, I will choose this plate to be positive, plus Q2, and this plate to be negative, minus Q2. I indicated the charges on the capacitors, current, charges on the capacitor, on the capacitors. Now I need to choose my loops and the direction in which I will go around these loops. I remind you that there are always n minus 1 number of independent equations. E dot dr is 0 if n is number of loops available. So which loop we will choose? My choice. I will choose, let me use green for loop 1. It's your choice. You just choose something and you stay with it. My loop 1 will be this. This is loop 1. Okay, so this way, and this way. Wonderful. Loop 1. Now I need loop 2. Which loop will be my loop 2? Let's choose this loop as 2. And then I need loop 3. And my loop 3 will be this small loop. So I will go this way around the loop, and this will be my loop 3. There is one more loop, loop 4, that will be this loop. But I understand that I have just number of loops minus 1 independent equations. 1, 2, 3, we are good. Enough. Now we need to write E dot dr for each of these loops. Loop 1. I start with the battery. I will describe it in terms of electric field, E dot dr. So voltage change across this battery is positive, which means that E dot dr is negative. That's why I put minus. Magnitude is V1. Then we come to this resistor. Current is flowing to the right, which means that J, current density, is to the right, which means that the electric field, which is rho J, is to the right. This is the electric field. You don't need to explain all these details every time when you solve this problem on the test. I just try to remind you how do we choose the direction of E dot dr, how we choose sign of E dot dr. So electric field is to the right. dr is to the right. They are parallel to each other, which means that dot product E dot dr is positive. I put plus here. Magnitude is current times current I times R. Then we keep going. Loop 1, we come here. Current is I. The same logic, electric field is to the right. What is dr? Again, to the right. So I put plus, and magnitude is IR. We keep going. Loop 1. Loop 1 comes here. Again, current is I. It is to the left, which means that electric current density is to the left, electric field is to the left, and we go in this direction. So our dr is also to the left. I put plus IR, and this is equal to 0. We are done with loop 1. Now loop 2. For loop 2, where do we start? Let's start with this resistor. Current is flowing to the right. We go in clockwise direction, which means that our dr is to the right. So dr is to the right. Electric field rho J is to the right. They are in the same direction. E dot dr is positive. I put plus. The magnitude of E dot dr, is IR. Then we keep going. This is loop 2. This is my choice of plus and minus charges. From plus to minus, my electric field is to the right. And dr is to the left. This is dr. So E dot dr is to the right, dr is to the left. E dot dr is negative, and magnitude of voltage, of change of voltage, or E dot dr across the capacitor is Q over C. So I put magnitude Q1 over C1, and this is loop 2. So this is equal to 0. Now we need loop 3. For loop 3, I will use blue. This is loop 3. Where is loop 3? Right here. Where do we want to start? I like to start with the battery. Why? I don't know. Let's start with the battery. So we are moving in clockwise direction. My DR is to the right. Voltage change across the battery is from plus to minus. Negative change in voltage means positive change in E dot DR. I put V2 plus V2. V2 is magnitude. Now we keep going. And where is my loop 3? It is this one. I have this resistor. Current is to the left. Electric field is to the left. And blue DR is also to the left. E dot DR is positive. I put plus. Magnitude of E dot DR across this resistor is IR. Then we keep going. This is our loop 3. So we come here with our loop 3 right here. This is my DR. Question is, what is E dot DR across this resistor? We already discussed this, that there is no current through the capacitor. So there is current in this, let's call it I1 or whatever. Current in this branch of this circuit is 0. So voltage change across this resistor, or E dot DR across this resistor, is 0. I is 0. Now we come here to this capacitor. Capacitor has positively charged plate on the right, so my electric field is to the left. This is the direction of the electric field. Electric field is to the left, but we go in clockwise direction. This was our choice and we stay with it. DR is to the right, electric field is to the left. They are anti-parallel, dot product is negative, that's why I put minus. And magnitude of E dot DR across a capacitor is Q, and capacitance is C2. Okay, and now we are back to the battery. We close the loop. This is equal to 0. Now we have 3 equations. Let's count our unknowns. We don't know current. We don't know charge Q1. And we don't know charge Q2. And that's what we need to find. So we have 3 unknowns and 3 equations. Problem could be easily solved.
Sorry.
By the way, I forgot to put Q2. Q2 is here. Q1 and Q2. So we have I, Q1 and Q2. That's what we need to find. Let's solve first equation for current I. From the first equation, I immediately get current I as V1 divided by R plus R plus R, 3R. This is my current. Now I know current. I can solve second equation for Q1. What is Q1? Q1 is C1 R, and then current I. And current I is V1 divided by 3R. R and R cancel out, so I have C1 V1 divided by 3. And all we need to find now is Q2. We will solve for Q2 using our third equation. Q2 is equal to C2 times V2 plus IR. And current I is V1 over 3R. This is current I times R, R and R. And we have our final expression for Q2 as C2. And then V2 plus V1 over 3. When you find your final answer for currents and for charges on the capacitor, please always check the dimension, because you do your calculations and it's easy to lose some term here and there. So the dimension of current is voltage divided by resistance, correct? Then dimension for charge that we found is capacitance times voltage, wonderful. And then Q2 is we add apples and apples, voltages and voltages, and then we multiply it by C2. So dimension for Q2 is also right. It's correct. So we found everything that we have to find.